right. So continuing and realizing that my hotkey to move my graphic around is the same as the hotkey to stop recording, let's work on this next problem. So we now have tangent, and this gets a little bit trickier. I actually would feel like I would rather solve this by turning it into like a cosine over sine over cosine. So this could also be expressed as sine of alpha minus beta over cosine of alpha minus beta. And I think that that's probably an easier way to end up solving this, is to just apply this rule twice, and then we can very quickly figure out the missing pieces of information from here to fill the rest of it in. So let's go apply that formula. So on the top here with sine, this is minus, and in the sine formula it is the same sign. So we're looking for sine of alpha times cosine of beta, same sign, so in this case minus, cosine of alpha sine of beta over the cosine version of the formula, which is cosine of alpha cosine of beta. And then this is minus, the cosine formula is the opposite sign. Sine of alpha, sine of beta. So at this point, we just have to go figure out the missing pieces of information. And the missing pieces of information that we need are going to be sine of alpha, and we need sine of beta. So this first one should be pretty easy. Again, if it's the sine of the same angle of cosine, it's basically just create a right triangle out of the values and just do the Pythagorean theorem. So it would just be 13 squared minus 12 squared, and we just take the square root of that. So 169 minus 144 would be the square root of 25. So we know that the missing side here is 5. So if we were to think about this as a triangle, we knew that the hypotenuse was 13, the long side was 12, and then this missing side is 5. So sine of that same angle would then be 5 over 13. This other one's a little bit trickier. I mean, it's the same process. I just don't have these squares memorized. So we've got 37 squared minus 12 squared. And so that would be uh, 35. So the missing side there is 35. So if we were thinking about that as a triangle, which technically I don't think I'm really drawing this right, but if we want to be more consistent, typically they get drawn like this. And when we're dealing with beta, we know that if this is angle beta, cosine is the adjacent over the hypotenuse. We calculated this missing side to be 35. So when we do sine of that angle, it's opposite over hypotenuse, so we know that sine is just going to be 35 over 37. And now at this point, we have all of the pieces of information we need in order to plug all this in. So we've got sine of alpha and then we've got cosine of beta, which was given, minus cosine of alpha, which was given, times sine of beta, which we had to figure out, then on the bottom, cosine of alpha, which was a given, times cosine of beta, which is the other given, plus sine of alpha times sine of beta. Now, I'm not too keen on doing that particularly by hand, so we're going to probably type it in and see what we get. And hope that GeoGebra keeps this in fraction form, because I don't have a TI Inspire particularly handy here. And we end up getting negative 360 over 319. And that seems like that's probably right. All right, so let's move on to the next problem here. So this one actually is a little bit easier because of, well, I mean, it gives us tangent, so it's basically kind of the same process. We use our formula to write out what we need. So this is cosine of A plus B. So we're going to write out that cosine formula. And the cosine formula is, and I'm actually always looking at it every time, cosine of alpha plus beta is equal to cosine of alpha times cosine of beta, and then use the opposite sign, sine of alpha, sine of beta. And then we just have to go figure out the missing pieces that we don't have. So it is pretty easy to figure out. We wanted to start trying to figure out sine of alpha. So we know cosine is adjacent over hypotenuse. So that gives us 8 and 7. This value here is whatever 7 squared minus 8 squared is. 17 squared. So I think that's 15. 15 squared. 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 15 So that way, if we want to know sine of this, sine is opposite over hypotenuse, so we know that sine is 15 over 17. Tangent, it's kind of the same idea. So if we want to figure out, we actually need to figure out both from here. So we're actually needing to figure out sine of beta and cosine of beta. And so, it's basically the same process. Tangent, if this is our given angle, tangent is opposite over adjacent. So we know that the opposite is 5, the adjacent is 12. That is a 5, 12, 13 triangle, so that's pretty quick. Sine is the opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. And now we have all the pieces of information that we need to be able to plug into here. So we'll start with cosine of alpha was given to us. Then cosine of beta was one of the ones we computed over here. Minus sine of alpha is one of the ones we computed. Oops. You wouldn't have the word sine there. It's just the value. And then sine of beta was the other one we computed. And then again, we would need to crunch the numbers on that. And so that's where a calculator would be very handy. And so we've got 8 over 17 times 12 over 13 minus 15 over 17 times 5 over 13. And this gives us 21 over 221. So not too bad. I mean, they really all fit the same kind of pattern. The next one that we're going to see of this type really just introduces the reciprocal trig functions. So we're looking at cosecant, secant, and then we're trying to figure out sine. So again, we write down the formula that what we need, and that's going to be, let me see. So sine is looking for sine of alpha, cosine of beta, and it uses the same sign that was there, so we have a minus sign, and then cosine of alpha, sine of beta. And now we're looking at this cosecant of alpha, so we can translate that into, if we have cosecant, that's sine. So sine of alpha is just 12 over 13. You can very quickly use the right triangle to figure out that cosine of alpha is going to be 5 over 13. So we just do that same thing, draw a triangle, figure out the missing side. And then with secant, that's going to tell us cosine of beta is 3 over 5, which means sine of beta will be 4 over 5. And at this point, we have everything we need. So we just go back through the process of plugging it all in. So 12 over 13 times 3 over 5 minus 5 over 13 times 4 over 5. And then punch it into a calculator. That one probably could actually do by hand. Then we get 16 over 65. And that looks pretty good. So let's move on to the next types of questions here. And actually, this goes back to, you could potentially make the argument that this might be using like the cofunction formulas, because 180 is pi over 2. No, that's 90. Okay, well, then they don't work. So we just do the same thing that we have been doing. So let's go write down our formula. I just closed my formula chart. So we're dealing with cosine, and our alpha is 180, and our beta is theta. So cosine will be cosine of alpha times cosine of beta, and then followed by the opposite sign, and then alpha beta. Sorry for those scribbles in the corner. My hand was getting cramped from how I hold it over this tablet. So cosine of 180, go back to just thinking about the unit circle. 180 is right here. That is the value -1, 0. So cosine of 180 is going to be -1 times cosine. Sine of that is going to be 0. And so that just wipes out that whole term. And we're left with negative cosine of theta. I like these ones a lot more than those fraction analysis, because those fraction ones just, it's so much number crunching. And I mean, we can kind of predict that this is going to behave very similarly to how the one we just did it played out. So we're going to put our formula here that if we have sine of plus here, it's going to have the same symbol in between. So it'll be sine of 360 cosine of theta, same sign, so plus cosine 360 sine of theta. So now we figure out what these sine and cosine values are. So my unit circle, there's 360. That is the value 1, 0. So sine is the y value. We know that that's going to cancel to 0. So 0 times cosine of theta just cancels out. Over here, cosine of 360 is 1. So 1 times sine is just going to give us sine of theta. All right, so I'm going to end this video here. I'm going to pick up the last set because I think those are a different topic. So I'm going to end the video here, pick up the next one.